Okay. I have a loud voice, so hopefully that it picks me up. But if not, we can. Let me get my thoughts together. So today is Monday. Happy Monday. I'm sorry you didn't have a snow day, but it was way too warm outside for that to happen. Which is probably a good thing because it's been frigid. 6-3 is today and tomorrow. Some of you are missing tomorrow as well. So I will probably do the same thing if there's something that I think is important tomorrow. Stay tuned. And then your long day is a work day. It's a review day. I'll have a quiz review for you because you have a quiz on Friday. So that's what's up this week. Great. Hopefully that gives you enough days where if you're gone or about to go to a meeting that you can get your questions about 6.3 answered. So here are the things that we are doing in 6.3. I'm introducing a new vocabulary word to you. It's called logarithm. It's fun to say. Logarithm. It is not a term used in music, believe it or not. Logarithm. Doesn't sound like.
Maybe a guitar thing.
Yeah. You know what would be a fun game? This probably already is marketed, so I can't patent it, but like where there's these words that nobody knows what they mean, like on a card, and you have to come up with the definition of them. Isn't that a game? I feel like I've played that before.
No.
You have to like come up with what you think the definition is. No.
What's the actual definition of that?
I don't know. But I just think it'd be funny to like put like words up and just
The closest one.
yeah, or just to be funny, you know. Like what is it? That'd be funny.
Our English teacher in 6th grade, he played a game to review us all dictionaries. He said we could think any word in the dictionary. Yeah, and he'd be able to define it. He always did. He always defined it perfectly.
Found the word in the dictionary?
No, we find the word in the dictionary, and then we tell him the word, and then he would define it.
Oh, I thought you said he would look it up. I'm
No.
like, that's not a fun
We
game.
looked it up.
Okay.
And he always like defined it perfectly.
Wow. He must have been really good at the SAT. Let's see. We're going to first talk about what in the world a logarithm is, because you don't know. You're going to graph logarithms and logarithmic functions by knowing the definition of an inverse. It's going to be fun. And using the graphing calculator. And then we're going to find the inverse of logarithms and exponentials. It's going to be a really great time. Yeah. It's a lot of words to write down, I know, but it's good for you. Get you ready for college, you know. Okay, so I have a question. So if we're thinking about, that's not a pen. If we're thinking about inverse operations, do you remember this? It's really just a fancy word for do the opposite. So what's the inverse operation of addition? Thank you. What's the inverse operation of multiplication? Okay. We learned that the inverse operation of a square root, right, was to square it. And then that happened no matter what the exponent was, right? Well, what happens if you have that? What's the inverse of it? Okay, but we can't x root because we don't know what x is. Yes, technically, but we don't know what x is, and so we can't do it if we don't know what x is. What did you say? X to the a? No, but that's a good guess. I like where that's going, and we're going to talk about that when we talk about finding the inverse of a function. But what is the inverse of an exponential? A logarithm! There it is.
We're learning about logarithms.
It is. And if you try to understand a logarithm that as anything other than the inverse of an exponent, you're going to confuse yourself. Okay? That's literally all it is. It's just like addition, subtraction, multiplication, division, logarithm. That's it. Okay, that's literally, it's a really big word. I wish they would have come up with a different word for it, but I was not around, so they couldn't take my opinion. Nor would they have, because in that time they didn't really respect women in the math and science fields, so I know. It's a real good thing I was not born then. So, well, you're still writing. So I'm glad you're here for this because, I mean, it's going to be on the video anyway, but. And I have a super cool acronym for you. Because, yeah, you Generation Z kids. See, you guys aren't even millennials anymore. Because were any of you born in the 90s? Shut up. That makes her feel old. Yeah, you guys are now Generation Z.
At this time, please release all sophomores to go to the auditorium for their class meeting. All sophomores, please report to the auditorium for your class meeting.
I am so much, Chloe.
You don't have to lie. You know how much she like talked about how you picked her for president. I told the basketball. It was a good half an hour as I was driving her to school. She's not gonna take me for president.
That's funny. But I did say on a desert island, if I were stranded, I would want Chloe. So, Chloe, it's okay. I had to tear you down to build you back up. Make sure you listen to the principals. They're going to tell you all kinds of cool stuff, like don't be tardy.
Yeah, basically.
Yeah.
Also, don't fight and don't do drugs.
What? You're not supposed to do drugs?
Yeah, like,
I didn't know that.
I'm pretty sure our classes
Because they want to know them all.
Otherwise, get a little bit more.
Otherwise, I wouldn't know that.
Yeah, yeah.
We have like the most tardies of detention.
Yep.
You have the highest attendance.
Yeah, they have the highest attendance. They sure do. That's probably why they have the highest. Well, no, you guys just got some interesting people in here, right? Okay. Oh, wow. Well, this will be fun. Okay, so this is how you write a logarithm. It's log. That's how you shorten it. The base, it's like a little subscript. So if you were to write it, it would look like this. It's just like a little bitty subscript. And then the way you guys like to say it is y is the same level as the logarithm. That's what a lot of people describe it to me as. So if you have something like log base b of y equals x, that's the same thing as saying b to the x equals y. So that's just the inverse of it, okay? Yeah, it's kind of strange. So we use this really awesome acronym, BAY. You guys use it to represent before anyone else. I think that's ridiculous, but nobody asked me, so. So the way that I like to describe it is B stands for base, A stands for answer, and E stands for exponent. Okay. And it's just to help you determine the order of things. So the easiest way for me to show this here is that the base stays the base. So the base of the logarithm is the same as the base of the exponent. Okay. Your answer, which is x, so this answer comes next into the exponent, so that might help you if there's an e next to it. The answer becomes the exponent. Okay. And then whatever's left over, this is the only thing left, so that means that has to be what it equals. Okay. Base, answer, exponent. Bay. Don't forget your bay. Gosh, that's weird. Anyway. Also, a logarithm has nothing to do with wood. It's not like logs, even though that's what it sounds like. Like Algebra 1 will look at my board sometimes if I write like log, and they're like, why are they learning about wood? Because that's what we want to learn about. Okay. All right. So we're just going to rewrite each in exponential form, and the really awesome thing about this is it should make sense to you. Okay? So the base, which is 2, stays the base. The answer becomes your exponent. And then whatever is left goes on the other side. Hey, it's 2 to the 4th, 16. OMG. Magic. It is magic. It has to be magic. It can't be math. It has to be magic, right? The base is the base answer. Whatever's left. Anything to the 0 power is always 1. We're going to learn that today in Algebra 1. Oh, man. That's going to be a tough thing. Great, do the next 2. Meet you at the end. Is that what you got? Yeah. I feel like that's pretty straightforward. I like that because it makes sense. Like, would you believe I still have people that will say, well, that's a bad example. People will say, 0 to the 4th equals 1. I'm like, what?
Yeah, 0 times 0 times.
Yeah.
0.
Yeah. Like, what? Anyway, I digress. I'm not going to air my problems to you. There we go. Now we're going to work backwards. So you start by writing the word logarithm. You have an exponential, so you need a logarithm if it's the inverse. The base stays the base. The answer comes next, and then the exponent. Base, answer, exponent. That's the number one most important thing in this chapter. Base, answer, exponent. Okay. And then a lot of people say, oh, then I can work backwards to make sure I did it right. Sure can. 5 squared is 25. Log base 10, 0.1. I would encourage you, I mean, you don't have to put it in parentheses, but parentheses are very helpful and they are important. So it's okay to still use them. Base is 8. The answer is 4. Exponent goes off the end. Isn't this so useful in everyday life? Answer, exponent. Great.
That's good enough.
I wish. I would rather do more on a Monday and give you work time on a long day. I like to front load my weeks. I like Monday to be real productive, Tuesday to be real productive, Wednesday, all right, Thursday, nothing, Friday, that's my week. Thursday and Friday, I'm like, weekend! Except it's not. I still have to be here.
There's a quiz on Friday.
Yeah, I know. So that's easy for me. Quiz days are the best days. Except when you all decide to cheat, then I actually have to watch you. That's annoying. Okay, so special cases. So if you have the logarithm of 1, it doesn't matter what the base is. So I'm just going to call it b. Okay? Let's see what the logarithm of 1 is going to be consistently. So what if you had the log base 2? By the way, the base can be anything you want it to be. Okay, there are some common ones we'll talk about, but it can be really anything. Well, I don't want to say anything, but anyway. What if you had the log base 2 of 1 was equal to x, right? You're probably like, what? That would mean that 2 to the x was equal to 1. 2 to what power would give you 1? Okay, what if I gave you log base 5 of 1 was equal to x? That would mean that 5 to the x equals 1. X has to be 0. So anytime that you have a logarithm of any base of 1, the logarithm of 1 is always going to be 0. Okay? So that's fun. Okay, the logarithm of b with base b. Okay, well, let's just try out a few. The log base 3 of 3, because whatever b is, it has to be the same in both spots, right? So that means that 3 to the x is equal to 3. Okay, so what does it look like it's going to be? 1. Okay, so let's just make sure that works. Log base 6 of 6 equals x. So 6 to the x equals 6. Now, my college professor would probably be really angry with me because you can't just generalize things because you want to, because it looks like it. You have to prove it. But I don't really want to prove it, so can you just take my word for it that it's going to be 1? Is that cool? Is that cool with you? Because I could do it, maybe. I feel like that would be an induction proof. That's not, my coffee isn't gone yet. It's raining outside. I'm just gonna. Are we cool with that? If you want it, I can do it for you, but I don't really want to. All right. So, this is probably single-handedly the most important thing I inherited from my host teacher when I was student teaching is this table right here. This is genius. I don't know who made this up, but it's genius. So we need to complete the table, and it doesn't matter which order we go in. So the exponent on 5, that will give us 25. So I guess the best one to start with is the statement in exponential form. So we want to know the exponent on 5. That's what that's saying. What is the exponent on 5 that will give us 25? Okay, you smart math people, what is it? It's 2. Okay, so the exact answer is that x equals 2. And now let's work backwards. The statement in logarithms would then be log base 5 of 25 is x. And then the logarithmic statement in words is literally what I just said.
Oh.
Yeah, so the log base 5 of 25. You could say, to me it doesn't matter if you say is x or is 2 because you've told me x is 2. The goal of that column is just to get you to understand the language because people come to me and say log 525 and I'm like, what? Because log 525 is different than log base 525. So you have to make sure that your language is correct or I'm not going to know what you said. So why don't you try that second one, and then we'll try the third one together, and I'll let y'all fly solo for a hot second. Because that's fun. So much fun. Do. Let's do this third one together, and then I'll let you complete the table. You might get stuck in a few spots. That's okay. I'm going to start with this next box. So we've got log base 3 of 27. We don't know what it is yet, so we'll have to wait. Maybe you do, but we'll come back. So I think, I don't know, what do you guys think? Which box should I do next? The statement in words probably isn't great. The exact answer, yeah. So the base stays the base. The answer, which is what we don't know, becomes the exponent. Oh, that's much easier to see. What's the answer? 3. Okay, so we can say is 3 right here. And then we can complete this box with the exponent on 3 that gives us 27. Beautiful. Got the idea? Cool. Complete the table. I will periodically write something on the board so you can check them. Silence is deafening. It's okay to talk to your friends. Chloe's not here. I don't know what to do.
At our basketball game, her brother walked up and he came up and hugged me before her, and that made him happy.
Jordan, I think it's going to be your personal goal for the rest of her high school career, at least, to prove to her that. That's funny. Hear that, Chloe?
And she's like, Jordan, I drive you to Smoothie King. Show some respect.
Oh, Chloe. What a gem. Cole, did you get the notes okay from Friday? I can't remember if they were posted or not because I haven't touched that since this time last year. So. Hey, did you do this one yet? Did we do this one? What is the value of x? Why is it negative?
Because it's 1 over 64.
Yeah. So don't forget about that idea of when you have a negative exponent, you flip that fraction. Are you cool with that?
Yes.
Okay, great. Man, it's a lot of writing. I got -3 for that one. Is that what you got? Beautiful. Can I go to the next one? You good, David? Okay. Last two here. What? Make, yeah,
Yeah.
two.
Freedom.
Freedom! Yeah, anything.
Let's see what's the easiest one.
Yeah, I did 3 to the x equals 9. You could have done 4 to the x is 16. You could have done a lot of things. You could have done 1 over 64 to the, or what would it have been? 1 over 8 to the negative 2 is 1 over 64. I mean, you could have done all kinds of crazy stuff. Yeah. Sometimes I wish I could give you guys the opportunity to come up with the hardest math problem you can think of, just to see what you would do. Good. Good, Jordan. Chloe, see if you can come up with something better.
She was gonna say 1 plus 1.
2 plus 2. 0 divided by 0.
On a math test.
Exponent 1, 3. It gives us 9. So the exponent on 5, that would give you 1 over 125. I believe that is negative 3, am I right? OMG. Okay. Log base 5. Stellar. That was hard work. I'm gonna have that table memorized by the end of my teaching career.
Now we're done.
Let me do D, and then I'll stop. It's a good stopping point after D to stop, because then we get into graphing, and I don't really want to graph on a Monday, so we're not going to because I'm in charge. Okay, so there are 2 common logarithms, because remember how I said that the base could be anything we wanted? So there are 2 basic ones. The first one is a base of 10. And when you have a base of 10, if you just write log like I've done right here, okay, I assume the base is 10. So if you forget a base, then that means that the base is 10. And if you look on your calculator, okay, there's a logarithm button right next to the 7. That logarithm button assumes a base of 10. Okay? I will show you tomorrow how to go in and put in a different base, but I don't want to show that right now. So, and then so that's called the common logarithm. We call it the common logarithm because it's the one that's most commonly used. The natural logarithm has a base of e. That is Euler's number. That is a 2.71, blah, 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 all that. That is a base as well, okay? And that is denoted by ln of x. I think it's Latin why they use ln, but the ln button is right underneath the logarithm button. And whenever you see ln, that means log base e. So on a test, you could write log base e of x, but you could also write ln of x. They mean the same thing. The ln of x is a little bit more sophisticated. Okay? So for these 2, all I want you to do is plug them in your calculator. Literally just type in log 8 like you see it. Don't make it any more difficult than it needs to be. And approximate it. I think Big Ideas wants 3 decimal spots, maybe. So, to the thousandths. I got 0.903. Is that what your calculator said?
Yes.
Great. Then you'll have to use that ln button for the next one. We'll look at the graphs of these tomorrow so you can kind of understand why. But I got negative 1.204. Is that what you got? Beautiful. Okay. That should be enough to get you started on your homework. You can either start now or not. I don't care. We'll get through graphing and solving, or not solving, but inverses tomorrow. So for those of you at home, thanks for watching. Hopefully you watched